And we're live.
So mark your own quiz. My good old favorite student.
That's not my name,
You know, irony would be if I ever did have a student named Ann Serkey someday, because that would confuse the heck out of her. And me. Shaq, what's the unit of force? So you can write N, or you could write out the word Newton, named after a scientist whose last name was? Newton's. Arguably the single greatest mathematician / scientist in history. It's not a coincidence that after he did his thing, the Industrial Revolution sprang into effect because, among other things, he invented calculus. Suddenly, engineering problems could be solved instead of guessed at. So, boom, there you go. What's its definition? Yep. Sure, that works. Did anybody say anything else for a definition of force? There's other ways you probably define it. If you had said mass times acceleration, I'd probably accept that, because you could have said maybe he's looking for the equation. I guess fine. Push, Ripple. 1 mark for each of those. Number 2. Emma, can you read to me question 2, please? Stop. Whenever it says net force, what they're saying is you don't need to go Winner minus, you don't need to go free body diagram. They've added all the forces together, and they're saying what if we represent it with one force is required. And the equation for net force, F net, is just MA. Also, Emma, how many marks is this question worth? You know what? I don't think we're doing a free body diagram, winner minus loser, multiple step. I think 1 mark is probably plug and chug. Did they give you the mass? Say yes. Did they give you the acceleration? And are you cluing in why it's worth memorizing what units go with what? Because I hope you didn't actually look for numbers. I hoped when I said, did they give you the mass, you looked for a kg. And when they gave you the accelerate, you looked for a mm per second squared. Way easier. Then go find the numbers that they're attached to. So Emma, if I hear you correctly, and I think I do, you're saying it's going to be 1,200 times 2. What's that, Emma? You think you can do that in your head without a calculator? Lay it on me, Emma. Units? Newtons. Okay. If you're wondering, 1 mark for the answer, half mark if you forgot the units. Sorry, take a half mark off. Yeah, whatever. How many marks was number 2 worth, Emma?
3.
Number 2, how many marks was number 2 worth? 1. Hey, how many marks is number 3 worth, folks? 3. I bet you that's a multi-step question. Are you hopefully you're in grade 11, you've learned those tricks on tests and quizzes, right? So, all right. Margarita, what are they asking me to find in question 3? Okay, you know what? I think I'm going to start out by going like this. And I'm going to say, did they tell me the mass?
Yeah.
Did they tell me the acceleration?
Yeah.
They did?
Oh, never mind. That's lost.
How do you know? Units. So let's go back to my question. Did they tell me the mass? Say yes. Did they tell me the acceleration? No. What did you say this question was asking me to find? It technically force, but you know what I'm going to spend most of my time finding? What am I going to spend most of my time finding? Acceleration. In fact, you know what? I'll draw a little line and I'll do the acceleration over here. Now I'm going to start to defic. Let's list what else they told me. You already told me that 770 was a velocity. Which velocity? Final or initial? How do I know V initial? What's V initial in any gun or cannon or artillery shell? I've watched enough movies to know that it always starts out at 0. I'm not going to tell you that. What else did they tell me? Oh, cool. Technically a displacement, but like you, I get those 2 words mixed up all the time because they both begin with D. And you said what I'd like to find is that. Hey, is there an equation that has VF, VI, D, and A in it? Hey, this is a nice review from the last unit. Cool. Could you be so kind as to get the A by itself for me, joy of my heart? Remember how tough this was? Hopefully it's becoming fairly second nature, and hopefully you're starting to clue in why I said it's worth learning to do this. Otherwise, I'd have to have you memorize every variation of the force equation as well. And there's more coming down the pipe. Who needs it? Oh, and you know what? I think I can actually even do that, can't I? Because VI is 0. So it's going to be 770 squared all over 2 times 1.5 Yeah, I can't do this one in my head. 770 squared all over. Well, I can do the bottom. 2 times 1.5 is 3. Save myself some typing. Now, I started to freak out when I saw that because that's a really big acceleration. Then I went, hey, wait a minute. Shaq, what is this question talking about? Artillery shell. That would have a huge acceleration. In fact, you know what, Curtis? I'd be worried if I got an acceleration of like 20. No. Bullets and guns and artillery shells have a huge acceleration. So at first I was a bit scared, and then I looked at the question and I went, no, actually, it should be big. So I'm going to write down 197633 because that's not my final answer, so I won't worry about sig figs yet. Margarita, what did you tell me this question was actually asking me to find? Oh. Right? So it's going to be mass, acceleration. But I'm going to use the answer button on my calculator instead of writing 197633. I'm going to go 65 times answer button. And I get a force of, I'll go to 2 sig figs now. I think the force is going to be 1.3 times 10 to the 1, 2, 3, 4, 5, 6, 7. You could write out that whole thing, but oh, for Pete's sakes. Units. It's a force. Newtons. Now, if you got that right, 3 out of 3. Otherwise, I'd probably do something like this. I'd give you a half mark if I saw that. I'd probably give you a half mark if I saw A equals VF squared minus VI squared all over 2D. I'd give you 1 whole mark for finding the acceleration, which means you're now at 2 out of 3. I'd probably give you a half mark if you went mass times acceleration, and a half mark for the answer. Now, if you got the acceleration wrong, but you went your wrong answer times 65, you'll still get a half and 1. Like a half and a half for a total of 1. Is that okay? By the way, when the barrel of this artillery cannon applies a force of 1.3 times 10 to the 7th newtons to the artillery shell, what will the artillery shell do? Rob, have you ever seen the old World War II footage or in the movies when they pull those artillery cannons? You see those cannons jump backwards like 5 or 10 feet, like 3 or 5 meters. And in fact, when they, now I was going to say when they pulled the cord, I doubt it's a pulled cord nowadays, but I've seen the old World War II footage. They pull and they jump out of the way because forces come in pairs. If you're going to apply a force onto the cannon shell applies a force backwards on the barrel and it recoils an awful lot. Ooh, Kurt, not only that, you're not being silly looking at your phone or anything like that. You wouldn't be that foolish ever, because if you were, you know I'd be coming over the table at you, right? So of course that I'm not, so you weren't. So how much force was applied to that cannon shell? 1.3 times 10 to the 7th newtons. When that cannon shell hits its target, how much force will it apply? 1 point, because it's going to come to a stop eventually. In other words, artillery shells do damage. There's why. I'm not that surprised by that big answer. I'm actually confirmed by that big answer. That seems right. Someone I was talking to earlier was like, this seems really big. No, actually, if anything, it seems the right size or small. Hey, Kyle, how many marks is number 4 worth? Bet you it's a plug and chug. What are they asking me to find in number 4? What did they give me? A newtons, which is a what? Means a force and a because now we have several ways to find acceleration. We could find acceleration using last unit stuff, velocity, time, distance, or now we can start finding the acceleration using forces. Okay, fair enough. So I think I can go like this. Oh, let's go back to red, Mr. Dueck. Kyle, how would I get the A by itself? Ah, boy. We won't bother memorizing that. We can derive it in 1 second. 12 divided by 1.2. Ooh, I'm going to argue, Kyle, that you should be able to do that in your head. What's 12 divided by 1.2? Don't let me down. Oh, thank you. 10 what units? It's an acceleration. Yep. Now, if I was being really fussy, why is that wrong? Magnitude's fine. Technically, it should be 2 sig figs, and because I just want you to remember when you write a 10 or a 100, that's actually technically only 1 sig fig. I'm not being fussy on sig figs this year, but I also know some of you doing chemistry. Is chemistry fussy on sig figs? Those of you that are in chem? So we'll reinforce it here, right? Turn the page. Or is it next page over? Next page over. I'm seeing a 1 mark and a 1 mark, so I'm seeing a 2-step question, but I have a feeling each of the subsections is only going to be 1 step. So A says, find the average acceleration. Well, it's either F over M. Oh, no, you know what? I think to find the acceleration, I think I'm going to use V initial is 0, V final is 3.2 times 10 to the 4th, T is 32. I'm guessing there's an equation that has acceleration, initial velocity, final velocity, and time? There is. Excellent. What is it? Get the T by itself. Get the A by itself, please. I'll give you a hint. A equals. Yeah. I agree with you. Which is going to be 3.2 times 10 to the 4th all over 32. Because VI is 0, that's just going to vanish, yeah? Actually, I think this works out evenly as well. Is the answer 1,000? Yeah? Meters per second squared. Now, technically, by the way, that's to 1 sig fig. If I was going to 2 sig figs, I would have to go 1.0 times 10 to the 3rd meters per second squared. Okay. That's a fairly big accelerator. Oh, it's a rocket ship. It's about 100 Gs. If there were people in there, they'd be in trouble because that's a fatal acceleration for a human being. But if it's a cargo ship, what do you care? What's the average net force? What kind of force, Shaq? You know what? Net force, no need for a free bot. Net force is MA. It's going to be, please tell me they gave me an M. 4.5 times 10 to the 4th times 1.0 times 10 to the 3rd. Is the answer 4.5 times 10 to the 7th newtons? I just added the exponents on the 10s because it's 10 to the 4th times 10 to the 3rd. I used math 9. Oh, and then I went 4.5 times 1, which is math 3, I think. What grade do you guys learn times tables? Is it, for me it was grade 3, but that was back in 1973. Grade 4? Okay. Number 6. You know what? 2 marks and 2 marks. I suspect this is going to be a little multi-step-ish. Let's see. A says, how far? What else do I know? I know VI is 0. I know VF is 12. That's not enough. You're saying, even though it says find the distance, I'm going to spend some time finding the acceleration? Okay. I think I can go like this. Right? I think I can go 1.6 divided by 6.4, which everybody knows is the same as 16 over 64, which everybody knows is equal to 1/4 or 0.25. It is 0.25 meters per second squared, yeah? I think. Okay, now I can kind of plug that over here, 0.25 meters per second squared. How does that help? Oh, I'll bet you there's an equation that has D, VI, VF, and A in it. I hope. There is? Which equation? Oh, and he finally got the D by itself. He picked up on my hint. God bless him. Keep going, Shaq. D equals what? I totally agree with that. Oh, and Shaq, you agree with me. I can go yoink. Yes? Conveniently. So it's going to be VF 12 squared divided by 2 times 0.25. You know what? I can do this in my head too, because 12 squared, that's 144. 2 times 0.25, that's a half. You know what dividing by a half is exactly the same as doing? Timesing by 2. It's going to be 144 times 2. The answer is 288, is it not? Yes? No? Yeah? Units. Meters. B. Time. Okay. Oh, I think I forgot to break some of these multi-step. I broke that one down. This wasn't multi-step. This is, you know what? I'd probably go something like this. 1 mark if you found the acceleration. I'd probably go a half mark if I saw that equation, and then a half mark for the answer. Something like that. Time. You know what? I think I'm going to use VF minus VI over A. There are probably other equations you could also use, but this is the cleanest, I think, because I know VF, I know VI, and I just figured out A. And we're at a stage now, I hope, Reed, where we can be comfortable enough using something that we just found to find something else. We've practiced enough that I think we can be confident. VF 12 minus 0. Hey, Reed, what is 12 take away 0? Really? That long a pause? Hey, Reed, what's 10 take away 0? What's 5 take away 0? What's X take away 0? Good. What's 12 take away 0? Divided by 0.25. You know what dividing by 0.25 is the same as doing? Same as timesing by 4. I think it's going to be 12 times 4, I hope, but I think the answer is 48 seconds. Is it? I hope, I think. And I would probably go something like this. 1 mark, half mark, half mark. Something like that. Then I would probably turn the page. A book is sitting on a level desk. You know what? Your binders are books. So I'm looking at your binders. Which of the following statements is true? Shaq, A says there are no forces acting on the book since it's not accelerating. Is that true? You know how we can figure it out? We could draw a free body diagram on the book. We could say, here's the book. And we could say, what are the forces acting on the book? What are the forces acting on the book, folks? Get the obvious one.
Gravity.
What else? Is the book sinking into the ground like quicksand? No, you say. Is it lifting into the air like Superman? No, you say. So I think vertically there must be another force the same size. What did we call that there force that a surface exerts? Okay, we got a good free body diagram. Now let's answer the question. Shaq, A says there are no forces acting on the book. Look at my free body diagram. Oh, because there's 2 forces at least. Half mark for that, because since there's 4 true-false questions, and it's out of 2. The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force on the book. Normal force equals mg. Is that true? It must be true, because if not, it would be unbalanced. The book would either be flying into the air like Superman or sinking to the ground like quicksand. True. Hey, what's the net force on this book? You know how I know? Because it's not accelerating. That's Newton's first law. D. Friction is what's holding the book on the desk. Well, I don't have friction anywhere in my free body diagram. And if I wasn't sure, I could just imagine if my desk was made out of ice, as long as it was level, couldn't I still put a book on top of it? So I don't think friction is what's holding it on the desk. Half mark for each of those out of 2. I like number 8, I like number 8, I like number 8. I don't know. Didn't say that. Maybe you're just the kind of student that tends to notice those things. Elevator questions. Now, although the question says find the scale reading, that's really not what this question is asking me to find. When they say find the scale reading, what are they really asking me to find? Normal force. Folks, can I give you some advice? Draw a free body diagram for each one of these. Now, some of you may be saying, Mr. Dueck, I can just figure out the equation in my... Draw a free body diagram. I'm setting you up, especially those of you in grade 11 who are taking Physics 12 next year. I'm setting you up for next year when the questions are tough enough that there ain't no way you're coming up with the equation on your own. But if you find free body diagrams a habit, and you've had lots of practice drawing them, you'll be in good shape. Speaking of, represent the mass with a dot for A. What are the forces acting on part A? Get the obvious one. What else? Why? The ground's pushing back up on him, which conveniently is what the scale is going to measure. Which way is this person accelerating? So should I draw the normal force bigger, smaller, or the same size as mg? Let me ask you the same question, but I'll phrase it differently. Who's winning? Just wide droop. Long. Okay, so my equation is going to look like this. Winner minus loser equals MA. What do they ask me if? Oh, normal force. How do I get the normal force by itself? $60 times 1.2 plus 60 times 9.8. Can I do this in my head? Well, they're both being multiplied by 60, so I could just multiply 60 times 1.8 plus 9.8. 1.2 plus 9.8. 1.2 plus 9.8 is, it's going to be 60 times 11. 660? Yeah. 660 what? Newtons. By the way, what's mg for this person? What's their mass? Can you go 60 times 9.8? What's their mass? Sorry, what's their weight? What is 60 times 9.8? Okay, 588. Normally, no pun intended, this person's normal force is 588. They're going to feel heavier. They're going to feel like their stomach is getting pushed down. It's not. They're accelerating up and their body has a backwards accelerometer. B. The elevator accelerates downwards at 2... Oh, did I say downwards? This is a job for a free body diagram. What are the forces acting on this person? Get the obvious one. Gravity. What else? But you know what? Since downwards is the acceleration direction, I'm pretty sure that normal force is losing. I'm pretty sure that my equation is going to be winner minus loser equals MA. By the way, if I'm marking these, I usually give 1 mark for that equation, half mark for getting the normal force by itself, and then a half mark for the answer. How would I get the normal force by itself here? I find it easiest to plus that over, at the same time minus that over. I think you'll get this. mg minus ma. What was the mass? 60. 60. Minus 60 times 2.25. All right, hot shot, Mr. Dueck. How about you do this one in your head? It's got like 3 decimals. It's got... Yeah, not going to happen. Did I do this wrong?
Missed a 0 on this.
I missed a 0. Knew something was wonky. One of the nice things about this method is there are some built-in error checks where it's like, yeah, I can tell something's gone wonky. 453? In English, we would say this person would feel an awful lot lighter. C. The elevator moves up at a constant velocity. Probably, oh, again, by the way, same as before. 1 mark, half mark for the answer. C. I would probably underline the word constant velocity. I'd probably still go with a free body diagram. I'd probably still say to myself, what are the forces acting on this person? Get the obvious one. What else? Am I going to draw the normal force bigger, smaller, or the same size as gravity? You know what? The nice thing about the tug of war is you can do it wrong and it'll still work. Let's suppose you said, oh, it's moving up. So you said, I'll draw it bigger. It's going to technically be a tie, but that's okay. We'll catch it here because we'll say, who's winning? And Emma, you might say, well, I think because it's moving up, normal force is winning. It's a tie, but that's okay. We'll do it wrong. And you said minus mg equals ma. What 2 words did I underline, Rob? What does that mean? In fact, the equation becomes this, because I could just plus the mg over. And then I can say, oh, normal force is equal to mg. It should have been a tie. If I really cared, I could go fix my free body diagram. Meh, I don't care. It's going to be 60 times 9.8, which was 588 newtons. Is that right? Wow, I got to wake up. I got the yawns here. Have to do some yelling to myself. D. The elevator is accelerating downwards at 9.8 meters per second squared. It's in free fall. Okay. Well, what are the forces acting on this person in the elevator? Get the obvious one. I agree. What else? You know what? I'm not sure. It's accelerating downwards. Let's just put a tiny normal force there just because we're not quite sure what to do. Who's winning? Loser equals MA. Once again, I could go yoink, yoink. I could say, well, it looks like the normal force is going to be mg minus ma. It's going to be 60 times 9.8 minus 60 times 9.8, because it says it's accelerating downwards at 9.8. Hey, what is 60 times 9.8? Take away 60 times 9.8. Turns out the normal force is 0 newtons. Really, I shouldn't have put an arrow there at all, but since I wasn't sure, again, the nice thing about this method, Jake, is as long as you're careful, it's not completely idiot-proof, but it will catch a lot of mistakes along the way. This quiz is out of, count 'em, 23. Can you give yourself a nice clear score out of 23, please? So we said this. We said, okay, friction, first of all, it's a Newton's third law reactive force. It's as big as it needs to be. We said it resists sliding. It's due to the microscopic hills and valleys between two surfaces. And in fact, the more hills and valleys there are, the rougher the surfaces. And we gave that roughness a name. We called it the coefficient of friction. Symbol? What's mu? I don't know. What's mu with you, right? Greek letter mu for the coefficient of friction. The coefficient of friction has no units. It's not measured in newtons. It's not a force. It's just a ratio. But it's a decimal, usually. The lower the decimal, the slipperier the objects are. The higher the decimal, like a mu of 0.9, would be pretty sticky. Velcro would probably have a mu bigger than 1 because it can hold its own weight and other mass as well. So you can have a mu bigger than 1, but not that often. Special situations, glue, certain kinds of rubber, Velcro. Most of the time, though, when we're talking about sliding objects, we'll have mu's between 0 and 1. We said that friction also depended on a second thing. At first, we were going to say it depended on the mass because we thought it was sort of how heavy an object was, because heavier objects are harder to slide. But we thought about it a lot, and you came to the conclusion that actually friction should not be equal to mu mg. Friction should be equal to mu times what? Oh, thank you for, I was scrolling down to the box, but you got it from, yeah. It's equal to mu times the normal force, which, if we don't muck around with anything, will be mg. But if we have a little fun and lift up or push down, or then it won't be. And we left off right here. We'll do a couple of more examples, and then I'll shut up. And I showed you the obstacle course video last day, right? Yeah, okay. I got a couple more to show you, but later on. All right. Says this, the coefficient of kinetic friction, remember we did say technically there's 2 types of friction. Technically, Trevor, there's friction when it's sliding, that's called kinetic friction, and there's friction when it's standing still, it's called static friction. But I said we're going to pretend there's just one type of friction. But it did explain why when you move something really, really heavy, getting it going is really tough, keeping it going is easier, right? Okay. Coefficient of friction between a steel block and an ice rake is small, 0.01. If a force of 24.5 newtons keeps the steel block moving at a steady speed, you know what? I'm going to underline the word steady speed. Then what's the force of gravity on the block? Valoria, what's this question asking me to find? I'll give you a hint. Look at the last phrase and find the word what. What is the what? You're right. You know what? It's want me to find mg. Oh, okay. Because that's what the force of gravity is, right? You with me now? Suggestions. This looks like a job for? I think we're going to start with a good free body diagram. Oh, sorry. So let's represent this block with a dot. Hey, what are the forces acting on this dot? Get the obvious ones. I don't know it, but I can label it. Read the question carefully. Does it suggest that this block is sinking into the ice like quicksand? No. Is it lifting into the air like Superman? No. I think we can reasonably assume Valoria, this is a guess, but I'll bet you, even though this question says find mg, I can't. But I'll bet you I'll be able to find the normal force. Oh, and then look, 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 look. I know another force the same size as the normal force, mg, which is what I'm trying to find. Hey, what other forces? It says that there's an applied force we're pushing. How hard are we pushing with a force of what? And when in doubt, I always push to the right. Oh, let's call this F applied, which is 24.5. Is there friction? Yeah? Okay, I'm going to draw friction pointing left. Tell me when to stop. Why is that wrong? What 2 words did I underline? So if we're moving at a steady speed, what do you know because of Newton's laws? What's your acceleration? Which means all of my forces have to be balanced. So you ready? Tell me when to stop. Yeah. If they hadn't given me that phrase, this question is impossible to solve. I'd need more information. But the fact that they told me that phrase means not only do I know vertically normal equals gravity, I know horizontally the 2 horizontal forces are the same. I'm going to start out going winner minus loser. I'm going to say it's moving to the right. I'm going to say, okay, well, winner minus loser equals MA. But what did we just say that A was? Really, I have this. Or, if I'm clever, what could I do with that negative F friction? Hey, watch this trick. Yoink. Ta-da! Ha-ha-ha! Eh? Eh? That's like math magic right there. Okay. Do I know F applied? Cool. 24.5. Look, what did you say earlier? Friction is what times what? Oh, don't let me down. It was in the little box you came through just 5 minutes ago. I was so proud of you. I was. Okay, he clued in to go look back. Hey, folks, our new equation, friction is what times what? Lay it on me, brother. Crap, I don't know the normal force. Oh, but look. I know another force the same size as a normal force. What? So, if I hear you correctly, we're saying this. Valoria, coming back to you, what did you tell me this question was asking me to find? Which is what in this equation that I've written here? How would I get the mg by itself? Oh, see how we're mixing and matching now, but we're using our skills. Basically, I'm saying, you know what? As long as they give me enough information, I can ask you to solve for any one of these little pieces, I think, in our free body diagram. I think I can say, apparently, mg is equal to 24.5 divided by mu, which is 24.5 divided by, did they tell me mu, the coefficient of friction, somewhere in the question? I hope. Oh, they did. 0.01. Dividing by 0.01, I think that's the same as timesing by 100. Double check me, but is it 2,450? Newtons. That's mg. Hey, by the way, I could have Michael given you the same question, but instead of saying find the force of gravity, I could have said find the mass. Because if I know mg, how can I get m? Divide by 9.8. If I wanted to, I could have said to find the mass, 2450 divided by 9.8. This object, has a mass of exactly 250 kilograms. Or that I could do that as a part B or something like that, right? Starting to combine everything. Dogs. This is the last one? We didn't see the Big Bang Theory video.
No.
Okay. A group of dogs is trying to pull a 220 kilogram dog sled. Oh, but they're unable to move it. Oh, these poor dogs. If the dogs are capable of exerting a total force of 432 newtons, what's the minimum coefficient of friction between the sled's runners and the snow? What's this question asking me to find? Mu. Cow says mu. Greek cow or physics nerd says mu. All right.
We need to draw a free body diagram.
What a great suggestion. This looks like a job for a free body diagram. By the way, you'll notice the way I know also there's multiple forces here. Compare with the quiz that you guys just wrote where the first half was just MA. It was always saying the net force, which is just one overall force. Here, I'm not talking about net force. I'm telling there's several forces. That's almost always a job for a good free body diagram. So here's our sled. You can draw the dogs if you want later. Hey, what are the forces acting on this sled? Get the obvious one. Darn right. What else? Is this sled sinking into the snow like quicksand? No. Is it lifting into the air like Superman? Nope. And I don't think this is talking about any other upwards or downwards forces, so I think we can reasonably assume that the snow is pushing up with a normal force equal to mg. What else? Dogs, the applied force, sure. Oh, these poor dogs. Which is 432 newtons. What else? Friction. Which way? Tell me when to stop. How do you know I have to stop here? Why does it have to be equal? It's not moving. You know what? This is the same question as the one above, although the one above I said steady speed. This is not moving. No matter what, a is 0. Now, if it was moving, they would have to give me the acceleration. Here, my equation is going to look like this. Now, in this case, a was 0, but if a wasn't 0, that's okay, Curtis. They would give me the acceleration, and I would have a number there. The rest of my steps would look a bit different, but I could still get whatever I needed to get by itself. In this case, in a lovely shortcut, I can say, hey! Friction is what times what? Mu times the normal force. So my next line, I think I'm going to go like this. What do they want me to find in this question? No, they don't want me to find the force of friction. They want me to find the coefficient of friction, which is not a force. They want me to find mu, which is different. It's what contributes to friction. I got to be fussy. So if you say friction, no, friction would be mu times the normal force. That's not what they're asking me to find. They're asking me to find a subcomponent of what makes up friction. Mu. How could I get the mu by itself? Do I know the applied force? But I don't know the normal force. Oh, but look. At my free body diagram, I know another force the same size as the normal force. What? mg. We've seen it's not always mg. We did one last class, Chi, where there was another downwards force and normal. We had to take that into account. But I said to you, most of the time this year, that'll be mg. But you will never hear me say friction equals mu mg. Friction equals mu times the normal force. I don't know the normal force. Look. I know another force the same size as the normal force. It's going to look like this. 432 divided by mg. What's mu? I don't know. What's mu with you? Mu is going to be 432 divided by, what was that? Oh, well, yeah. 220 times 9.8. By the way, that what's mu with you? Completely new material. I only thought of that dumb joke before Christmas, even though I've been teaching physics for 10 years. Oh, I've been missing out for 10 years. Which is why I'm flogging it to death so much. What's mu? What's mu with you? Okay. I was kind of proud of it. That's a little bit messy. Help me out. What is the coefficient of friction? Sorry? I can't hear you. 0.2? Yeah, even? Not 0.2 blah blah, 0.2 even? 0.20. Oh, you know what? I'll add a 0. I'll go to 2 sig figs. Units. There are none because it's actually newtons over newtons. They would cancel. Now, you'll notice I said this because it's possible friction could still have plenty of room to spare. These dogs are pulling with 432 newtons, and the sled's not moving. It's possible that friction, Kyle, might be capable of applying 1,000 newtons or 2,000 newtons. I don't know, but it's clearly capable of applying 432 newtons. That's why I said minimum coefficient of friction. A couple of comments. Kai, in your homework, there's also going to be questions where the acceleration isn't 0. Okay. They might say, find the acceleration. How would you get the a by itself? Well, divide by mass. We did a couple like that earlier today, too. Or if they give you the acceleration and they say, find mu, okay, it'll be a bit trickier to get the mu by itself, but it's all doable. Minus stuff over, plus stuff over, and divide to get whatever you want to by itself. We practiced the formula manipulation, believe it or not so much for last unit, although it was handy, but for the rest of this year so that I can throw curveballs at you, and they're not curveballs. In other words, I don't have to do every single possible example with you so you can start to figure some stuff out. Emma's looking at her watch. What's your homework? And then I got a couple of videos to show you. 1 is good. 2 is good. 3 is good. 4 is good. 5 is good. You've assigned everything so far, Mr. Dueck. Yeah, no. I said 7?
No, except 7.
Oh, I skipped 7. Good point. Blah, 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 blah. Well, definitely elevators. We need lots of practice on those. I'm going to say 6 is bonus. You can try it. 6 is harder. You know what? I'll say this. Look, 6 is tougher than I'd probably throw at you this year on a test. I would certainly expect my Physics 12s to be able to handle it fairly straightforwardly, but by then they've had kind of a year for this to sink in. So I'm giving 6 with the understanding that many of you are going to say, oh, and I'll probably go over it next class. Also with the understanding that you actually have like a full half hour plus to work on this. My other block probably won't get as much time because they got hit by an assembly, so I'm behind with them. A couple of videos to show you. This is a clip from the Big Bang Theory.